Whoa, okay, listen. Midpoint. Midpoint. Super tough, I'm telling you. Midpoint just means the middle point. So if I draw, ooh, let me try that again. That's pretty rough. If I draw a segment, that's still pretty rough. If I draw a segment and I want to find the midpoint, well, that would be the middle of the segment, right? And just to discuss some things, can there be a midpoint of a line? Like, can a line have a midpoint? Like the things with the arrows on the end? And the answer to that's no, because a line's infinite. So there's no way that a line can have a midpoint. Neither can a ray, okay? But a segment can. And that is where it is cutting these two parts into congruent pieces. Little slash marks mean congruent. So what I've drawn here is a segment where the two parts of the segment are the same length because the midpoint is present. And so basically this segment will be equal to this segment. So that's what midpoint means. So midpoint, big term. It's kind of the same thing as bisect. If you ever seen that term. So midpoint and bisect, they mean almost the same thing. And bisect means that it's cutting something in half. A midpoint does that. A midpoint will cut a segment into two equal parts. All right, so let's look at an example of midpoint and how it's used. All right, so let's just read this. D is the midpoint of EF. ED is 4x plus 6, and DF is blah, 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 7x minus 9. We need to find ED, DF, and EF. All right, well, to do that, we need to first recognize what we're trying to do. And last time I checked, we're looking for the distances of all of these. Okay, again, don't be that person that says, well, ED is 4x plus 6, so I'm done. No, because you're going to have to find x. And in a lot of cases, that's the case. So what you need to do is you need to find x. If D is the midpoint, then we're going to use the definition of what midpoint means, and that means that these are congruent. Which also means that the two segments are equal in length. Therefore, ED's length is the same as DF's length. That E is looking pretty wild. All right. So ED is equal to DF, right? So that means 4x plus 6 is equal to 7x minus 9, right? And now we have an algebraic equation that we can solve. And to do that, we are going to subtract 7x, which is going to give me negative 3x plus 6 equals negative 9. Then I'm going to subtract 6 from both sides. I'm going to get 3x, my bad, negative 3x, equals negative 15, right? Then you divide. So when I divide by negative 3, I'm running out of space here. Let's just divide by negative 3. That's going to give me x being equal to a positive 5. But again, that's not my answer because remember, I'm trying to find each of these pieces, right? So let's go ahead and find ED first. So to find ED, all we do is take our x value and plug it in where I see x. Okay? So that would be 4 parentheses 5 plus 6. 4 times 5 is 20. Plus 6 is 26. Right? So now I'm going to look at the other side. If I plug 5 in here, I better get 26. Right? So I'm going to get 35, because 7 times 5 is 35, minus 9. So DF is equal to 7 times 5 minus 9, which is 26. Then that means my total, which is EF, is going to be those two added together. I know you don't have nothing to plug in, right? You don't have an x value to plug in for EF. You just have to recognize that these two shapes added together are going to give you that whole thing, which is what we discussed in segment addition. So 26 plus 26 is 52. And this is the application of midpoint. Basically, it's going to cut something in half, a segment in particular, and it's going to make sure that you have two congruent parts. Okay? All right, now have a good one.